AP Calculus AB, volume of revolving a region bounded by, in this case, y equals the square root of x, y equals 0, and x is equal to 4. And we're going to revolve that about the line x is equal to 4. So it's going to look like this really quickly. It's going to look like this. Right here's the line we're going to revolve this thing around. And as we do revolve it around that line, this thing is going to spin. Right, this is the axis that it spins around, and it's going to end up over here, isn't it? It's going to end up over here, and then as it spins, it's going to leave it's going to have a volume that goes from here, right? Volume, and then this volume here, and this here, maybe a little bit like an umbrella or something. So we're spinning it this way. This thing is spinning like this, right? And it's going to leave this solid here. Okay? So let's see what that would look like. First thing we're going to use is we're going to kind of use the washer method here. So I'm going to say that we're not using the washer method because we're looking for, it says about the x-axis. So when we get this is I guess what I really want to make sure you get, is when we're getting our volumes and adding them together, right, we're going to be taking these circular slivers out. And if you look at it, like it's this one, right? That one is this one. And then if you were looking down at it, then, right, is this one, isn't it? Do you see what I'm doing here? So it's spinning around this way. So our volumes are going to be these chunks taken like this, right? These horizontal slabs, right? They're three-dimensional, right? And then we're going to take the volume of this whole thing, right? And I keep reminding people, it's the same way as like finding the volume of this is not a hole, this is just that radius of this piece up here. That it's like finding the volume of a quarter. You just take the area of the face of the quarter, right? You take pi r squared, and then you'd multiply that by the volume, by the depth of the quarter, and you'd have its volume, wouldn't you? So this is what we're going to do. Here's the formula that we're going to be using, is that volume is equal to pi times the definite integral, a to b, of ry squared minus little radius squared dy. All right? So this is where I'm going with this. Where I'm going with this is, what is the radius of this solid? Well, the radius is no more than 4. So as I start to put this together, I'm like, the radius is no more than 4. How do I know that? Because here's 4 right here. So the next radius on top of it would be this blue line, and hopefully we can agree that this blue line is shorter than that one. The radius keeps getting smaller, doesn't it? As this thing gets taller, the radius gets smaller, doesn't it? And smaller and smaller and smaller, right? So what we would say, first thing we're going to do is this. Because we're looking at it this way, we have to convert this piece. So solve for x, and x would equal y squared. Is that okay? So now what I'm going to say is this. I'm going to take the volume, and the volume is going to equal pi, right? And now, because now my intervals from here to here, so it's 0 to 2. I'm looking at this thing as if I had spun it this way, right? 0 to 2 of, well, what is that radius? The radius from here to here is 4, isn't it? Right? It's 4, and then I'm going to go up. That's why this change in y, right? I'm going to go up until I get to a height of 2. That's why this, right? Well, the radius is 4, but as I move up, it's 4 smaller than 4, so it's 4 minus what? Well, it's 4 minus y squared, because that's this function here, isn't it? Quantity squared, right? Right, and the radius of the very smallest piece up here, and it's weird because all I'm saying is this line right here is what it's spinning about, and it doesn't have any depth, so it's going to be 0 squared. And right now you're like, that's stupid, why would you even say it? You'll see why on the next video, where we're going to have this thing spinning around a line that's outside here. It's going to create a hole in it, so that's going to make a lot of sense to you later. So let's just go with this, and let's expand this out. So we say that the volume is equal to pi times the definite integral 0 to 2. And when I expand this, I'll get 16 minus 8y squared plus plus y to the 4th, right? dy. All this notation is really important on the AP exam, so let's make sure that we're using it. So from here, we're ready to integrate. So I'm going to go ahead and integrate and drop the integrand. So I say that volume is equal to pi. Well, the first integral of 16 is 16y. Remember, we're dealing in y's, right? Minus 8y cubed over 3 plus 1/5 y to the 5th as evaluated from 0 to 2. Hopefully that's making sense to you. From there, we can do something different, I hope. And from there, what I would probably do is start evaluating this. And remember, this is crucial, that we're going to use the fundamental theorem of calculus, right? Fundamental theorem of calculus, which says that the area is f of b minus big F of a. That's the area. Remember, we're trying to find volume, so we have this multiplier out here. So that gives us that rotation there, right? So I did all this math out. Let me just show you what I got here and how I did it. We don't have to evaluate f of a because it's 0, and that's going to all go to 0. So we just have to do this. So I had 16 times 2 minus 8 times 2 cubed over 3 plus 1/5 2 to the 5th. And I remember this value of pi out here. If you're still with me, you're amazing. This gives us 32 minus 64 thirds plus 32 fifths all times pi. Can't believe I'm going to actually do all this math out, but what the hell, let's do it. Here I see the greatest common factor of these three things is 32, so I'll take 32 times pi times 1 minus 2/3 plus 1/5. This all converted to 15 fifteenths. This converted to 10 fifteenths, and this converted to 3 fifteenths, which gave us a total of 8 fifteenths. So we have 32 pi. I really must care about you guys. This is ridiculous. 8 fifteenths for a total of 256 pi fifteenths is equal to our volume. If you were taking the AP Cal exam, no lie, I'm going to find this out for sure, but I'm 99% sure you'll get credit just for setting it up. So show your calculus. Your arithmetic is less important than your calculus. Good work, you guys.